Hi everyone, welcome to Canada Technical Summit 2025. As Mr. Shrikant mentioned a lot about Wi-Fi features and everything, we need to perform a lot of testing for all these features. So in few minutes, I will be talking about how the testing evolution has been changing from labs to test houses. Just assume that in traditional days, we have a house with only a few devices that are connecting to the Wi-Fi. But nowadays, we have multiple devices that are connecting to your Wi-Fi. Similar like laptops, couple of laptops, speakers, all these things require a good Wi-Fi connectivity to perform day-to-day activities. Along with these things, these devices can be placed in a different distances. Some are placed near the house and some are like placed at the edge of the cell of the Wi-Fi. All of these things need to be tested. And if you consider a real house, we have a different interference, like we have the temperature. Temperature keeps on changing from time to time. The people will be walking around the floor, and we have the neighboring Wi-Fi network that is popping on the same channel or the adjacent channel. And we do have the weather and the humidity will be changing. And suddenly, if we enable any micro oven, there will be some interference. Even with all these things, we have walls and furnitures that may affect your Wi-Fi signal. So yeah, doing all the features testing in a lab is great, but some of the features that may not able to replicate in the lab. So we need something which is very closer to the end house. That is where we are setting up a test house that is like a mimic of real house with all these interference. Yeah, doing all the testing in test house is great, but it has its own challenges. I will be talking in a minute what are these challenges. But before that, I would like to share some of these things. Like some of the common test suits we are performing in the test house is like coverage, where we are evaluating your DUT or the access point, how well it is performing without any dead spots. And coming to the capacity, like where, as I mentioned, if we have like multiple devices, like 20 or 30 devices that are placed in different places of the rooms and are connected to the Wi-Fi, how your Wi-Fi is been working. Now, let me talk about some of the challenges performing coverage testing manually. Here, the biggest challenge is that the engineer one has to go and this is the house, this is the floor map of the house, where an engineer has to go to each and every test point and he has to connect his mobile or laptop to the Wi-Fi and he has to manually record what is the RSSI and he has to run the iPerf tool to simulate the traffic. And all of these things will be very time consuming, and the engineer one might be holding a laptop or the device in a certain orientation. If the engineer one changes and engineer two comes in the picture, the entire results can be changed because the engineer two may hold the device in a different orientation than engineer one. The distance of holding the device can be different. All of these things can be difficult to replicate the same results again and again. So here, once the testing is done, he is updating all the results in the spreadsheet manually and creating some heat maps like this. After creating all the heat maps, he is formally creating a report and writing all the analysis. This itself will be taking like 1 or 2 days only for the execution. This is a great time consuming. Now we do have some smarter way to perform this testing. Saurabh will be continuing that.
Yeah. So now we know about the manual challenges, what we face. So one of the biggest challenge or the challenge what we have is like human intervention. So how about like we can automate it, right? So what we can do? So what we did is we have placed a robot into this test house, and what it will do? It will automatically go to the test points and it will collect the data and it will give you the report. So like as you can see, so remotely the user or the tester can just go to this dashboard, select the points where he wants to cover the test, and he just click on run. Now what the robot will do, the robot will go to the certain coordinates, the test points, and it will start gathering the data. So in runtime, what the user will see? So in the runtime, the user can see the actual data, like what's being running, and like how the signal strength is on the certain points. So that all information the user can see remotely and can cover the whole test coverage from a single click. So it's a smarter way, and we can see that, okay, it's not just like, okay, the only point. So if you see in that case, like when you go to like, okay, it's not just a plus point for the robot, but if you go to like the more specification, so once you keep a client on this robot, you will see that, okay, unlike the human behavior, it will go to the specified path, and at the exact same angle, it will try to run the test every time. So here we are just removing that, okay, like seems like it's like more accurate. So if you see, the robot will go more accurately to the all points and at the same angle. And also the client which we have added in the robot is always placed on same height and same angle. So every time when you run the test across different firmwares, you will be seeing the same exact information or the inputs from the reliable resource. So here, once the test ends, you will be seeing a report, end report, where you can analyze the whole scenario which is being ran. So say, for example, after a week, you want to see the report, like what happened, and you want to cross-verify across multiple firmwares, like how my AP's specific firmware worked. So they can look into this and they can get an exact acknowledgement, like, okay, if my AP is placed somewhere around the floor plan at one point, and if my client is moving from one coordinate to another, like what is the RSSI or what is the signal strength he is getting, how much throughput he is getting, and the other stats, which can be useful for the analysis. So with a single click in a smarter way, the user can get the whole acknowledgement at the time, and they can get most out of it from this automation. So what topology we have used? So we have a setup where we have two setups in this. One is stationary and one is remote. So in the stationary, we have like a traffic generator, which is connected with a device under test, and which is used for pumping the traffic or like running the traffic. On the remote side, on the robot, we have placed a controller which is connected through a real client, and which can be useful for controlling the clients to perform certain tests, like real application tests like Zoom, YouTube. So from this, this is being connected through a backhaul, and this is how the robot topology is. Yeah, so Akhil will cover about the next step.
So the second test suite is like capacity. As the name suggests, like we have a lot of devices in our house, and if all these devices are placing in a different places, what will happen to your Wi-Fi, right? And how we can perform. So let me picture into an engineer role again. And for an engineer one, it is very hard to perform. Like if we have like 30 devices, he has to go to each and every device and he has to connect them. It's like, and he has to parallelly run the test. So he required another helping hand, maybe one or two engineers to help him to connect all the devices, and also collecting the logs while he is running the traffic, making sure all the clients are not going to the sleep state, and all the devices are being running in the test suite. After creating all the testing, he has to, so the disadvantage of this thing is like engineer 1 and engineer 2 are working in the test house. For example, few devices are just disconnected in one of the area. Engineer 1 will be saying to engineer 2, hey, device 24 was disconnected. But in the head of the engineer 2, he don't know where the device 24 is. It's very hard to picture inside the mind, right? So that is one of the difficulty. And after completing all the testing, he has to create these types of charts manually, and making sure to show like how many devices are connected to which node and what band. This itself will take a lot of time for multiple engineers to perform this type of activity by manually. Now we have a smarter way as well. Saurabh would like to continue.
Yeah. Hello. Yeah. So yes, we can solve this using the automation. So let's imagine you have a floor plan, or like you have a test house, and it's a bit difficult to map the devices or to visualize where devices are. So just like in this dashboard, you can see you have a floor plan where you can actually map the devices onto the specific location where they actually are. And what you just have to do, so if you have to control them, if you have to configure those devices, so you just need to select those devices and just click on configure. So it will start configuring the devices on a single click, and you will be seeing the actual, like how those devices are getting connected, like what are the devices not connected, what are the real-time stats, the Wi-Fi logs, just on a single click. So as you can see, like we in the floor plan, we can see which specific devices got connected and which are not. So if you want to further analysis, you can just go into the logs, which we already populate, and you can see like, okay, is there something related to the signal issue, the device is not connected, or is there any other issue? So like we can even segregate these devices based on bands. So it's pretty hard to visualize, like if my clients are segregated all across the test house or this floor plan, how they are connected with. Are they connected with a specific band, right? 2G, 5G, 6G, right? It's a bit difficult. So from this dashboard, you can easily see or visualize that, okay, through which band my devices are connected, to which access points. So say, for example, you have a mesh network and you have segregated the devices. So which devices are connected with which mesh nodes? So that you can see from here. You can visualize all the data from here, and even like when you run the test. So say, for example, you are running some test locations like this. Yeah. So say, for example, you're running some real application test, and you want to see like, okay, how my devices are performing, what are their signal strength, are they getting band steered, are they getting roaming? So say, for example, you are adding too much load on some client which are very far from a distance through which it's connected. So like how you can get those analysis? So from here you can get an acknowledgement like, okay, how the test is running, what are the signal strength, and many more details. So this is just on single click. You can visualize this whole scenario, and from using this dashboard like this, you can automate the whole testings to solution, and you can see this. So at the end, you will get a report like which will acknowledge that, okay, like the clients which are connected with a certain AP1 or AP2, how they performed. So what are the signal strength at the end? So those information, you can get it from the end report, including per device analysis. So say, for example, your device located at 100-meter distance from the AP, how it performed. So you can get all of those information right from this report, which is being generated from the user interface. Yeah, do visit our demo booth there on the site, so like you can get to know more about the solution. Thank you.
Can we have questions? Yeah, Chetan.
The roaming test that you mentioned, right? Is that extendable for like an AP placement or extender placement also? We have this, when extenders placed farther away, the LED indicates differently to test that. So can that be accommodated in this roaming test? Instead of stations roaming, we have APs moved to certain locations.
Yeah, that can be done. Like for example, we can keep the extender on the robot and the root device in the corner of the house or in the middle of the house. The robot will be moving along with the extender. Okay. So we can check the backhaul links between the root and the leaf. Yeah, that we can do.
Okay. Yeah. Also in the test house setup, the fans is a major interference source. Is that also considered in your test house?
Yes, as you said, like these are the external interferences. Like for example, these fans, when we are running and all these things, we are seeing some noise getting generated. This is affecting some of the signals to some of the clients. Okay. That is especially the clients which are sitting in the corner of the house.
Right. Okay. Yeah. But your test house does include multiple fans.
Yes,
and
yes.
Okay. Yeah. Thanks.
Can we have next question? Any questions?
Okay, please give a round of applause for Akhil and Saurabh. Thank you so much. Thank you.
Thank you.